Course 3, Lesson 75, we are looking at the area of a trapezoid, and in this video we'll also be looking at 76, where we are finding the volumes of cylinders and prisms. So first of all, for the area of a trapezoid, it has 4 sides, but it's unfortunately different from how we find the area of a rectangle or parallelogram, which we normally use area equals base times height. Unfortunately, with our trapezoids, we have different size bases, okay? So we have these parallel sides here, base 1 and base 2, but our other sides are not parallel, which means that our base 1 and base 2 are different sizes. Because of this, if we were to just use the base times height method, if we used our smallest base, we would be covering only this shaded part, and that's too small. Okay, we would be missing all of this triangular piece. Whereas if we used our second base, we would be adding too much. This would be too much because that's not part of the trapezoid. So instead, we use this formula, 1/2 times base 1 plus base 2 times the height. Now it's kind of curious where this comes from, so I'll try to explain why this is happening. For this, you can actually try this activity on your own. Basically, take a piece of unlined paper, or lined, it doesn't actually matter, and make a trapezoid. So cut off a couple triangles so that your bases are different sizes. What you're going to do then is label so that the top, okay, the smallest one is base 1, largest one is base 2, and we know that this whole thing is the height. So I would actually draw on your paper that this piece is height. And then you're going to fold that trapezoid, kind of hot dog style, so that there's a crease right in the middle here, and you're going to cut it so that you have these two exactly the same pieces for the height. So the height has just been divided by 2. And what you're actually going to do is, if you're doing this activity at home, you can take those 2 pieces of trapezoids and turn them, pivot them, so that this base 1 is right next to the base 2. And amazingly, it creates a perfect parallelogram, which we can say the area of a parallelogram is just base times height. That's what we've looked at before. But in this case, our base is actually this whole base 1 plus base 2. So our base right here is base 1 plus base 2. And our height is actually only half of our original height. So we would say that's height divided by 2. And that's exactly where we get our trapezoid formula. We say we have base 1 plus base 2 times height divided by 2. So that when we look at our trapezoid, we can try it and plug in some different numbers. So we need to replace the shingles on this roof, and she has a trapezoidal roof. And so we need to find this area. And we're going to do 1/2 times base 1 plus base 2, so 8 plus 24. And then we're going to multiply by 12, our height. Remember, always when we're looking at heights, it's going to be that perpendicular to our base. And in this case, our height is perpendicular to both bases. So I'm going to do 1/2 of 32 times 12. And when you do this, you can either cut in half the 12 or cut in half the 32, or multiply them together and then cut them in half. But regardless, you get an answer of 192 feet squared. Alright, so we're just plugging into our formula now. So if we have the bases of a trapezoid are 12 centimeters and 18 centimeters, the height of the trapezoid is 8 centimeters. What is the area? Now a trapezoid will look like this. Okay, we'll have our different units there. And so we're going to add these in and say 1/2 times 12 plus 18, and then multiplied by our height of 8. So we multiply these together, and we get 1/2 times our 30 times 8. So we get 120 centimeters squared. Alright, I'll leave these to you to try. You can, remember, add up your bases. To be honest, it does not matter what you choose to be your base 1 or base 2. Okay, but you can try these. Now remember, your height must be perpendicular, so you can see this perpendicular height in this fourth one. All right. And here's one last one if you would like to try it. Now let's look at lesson 76, okay, also looking at geometry. But with our lesson 76, we are looking at the volumes of prisms and cylinders. So we've looked at how to find the volume of like a cube or a rectangular prism, where we said volume is length times width times height. Unfortunately though, that's only going to work for our rectangular prisms. So we actually had another volume formula, area of the base times the height. So in this case, we would find the area of the rectangular base and multiply it by the height. We are going to use this second volume formula for all of our 3D solids because it is the most versatile. We only have to find the area of the base in order to find the volume, and then just multiply by the height. So first of all, let's make sure we know what is the base of a solid. So if we have something like this top right picture, this is called a triangular prism, and amazingly, the base of the triangular prism is a triangle. Because remember, a base has to be parallel to the other base. So we have this triangular base, which is parallel to the other triangle. Okay, so we have to say, yeah, that is the base, this triangle. It's not any of the rectangles because those are not parallel to each other. We only say it's the triangle. And the cylinder, the base is the circle. So just to remind ourselves, all we really need to know is what is the area formula for these different shapes. And for the triangle, we would say the area formula is base times height divided by 2. And the area of the circle is pi r squared. And the only thing extra we need to do to find the volume is multiply it then by the height, which is always that distance from base to base. It may not look like the height always, but it's the length from the base to the base. All right, sketch the base of this triangular prism, then find the volume. Well, if this is a triangular prism, then the triangle is the base. And in this case, we have a triangle that's 6 by 8 by 10. Which means to find the area of the base, I'm going to be doing 6 times 8 divided by 2, or 24. So we see that the area of the base in this case is 24, so we plug it into our volume formula and say we have an area of the base that is 24, and then we multiply it by the height. Now remember, the height goes from base to base, so in this case it is 12. So the volume of this solid is 288 centimeters cubed, since we're talking about volume. All right, a AA battery is about 50 millimeters long and has a diameter of about 14 millimeters. Find the volume of the battery. Well, let's draw a picture first. So we have this battery, and we say the diameter here is 14, and the length of it is 50, which in this case, since we're talking about volume, we actually say that's the height. So for our volume formula for a cylinder, we're saying, well, the area of our base is actually pi r squared, and then we'll multiply by the height. So we say, all right, that is 3.14 times, well, 14 isn't the radius, it's the diameter, so we have to cut that in half to get 7 as a diameter. And you know what? They actually asked us to use 22 over 7 for pi in here for a specific reason. And then our height is 50. So our volume here, we're going to be doing 22 over 7 times 49 over 1. Now we can see why they wanted us to use that, because we can simplify here. Then we'll multiply by 50. When you do that, 22 times 7 times 50 gives us a volume of 7,700 millimeters cubed. Okay, so think about how to find the areas of each of those parts, and then just plug it into your formula. All right, the figure shows a triangle that has a base of a triangular prism. The height of the prism is 10. Sketch the prism and find the volume. Well, what they're saying is that we have this triangular prism, and I'm just going to add another triangle here so that we can make this into our triangular prism. And they are saying that the height, so from base to base, is 10 centimeters. Well, to find the area or the volume of this guy, I'm going to find the area of the base times the height. And the area of the base is going to be base times height divided by 2, so 4 times 6 divided by 2 times the height of the prism, which is 10. Which means our volume is just going to be, well, 24 divided by 2, so 12 times 10, which is 120 centimeters cubed. All right. And I'm just going to do a couple of these. Buster has 2 empty cylindrical soup cans. The smaller can is 2 inches in diameter and 3 inches in height. Okay, so I'm going to draw that really quick. So we have 2 inches in diameter, 3 inches in height. The next can is twice as large, which means I have now a diameter of 4 and a height of 6. Find the volume in terms of pi. Well, that means I need to do pi r squared times our height, which in this first case means I need to do pi times my radius is 1, well that's not going to change anything, times 3 my height. So my volume is 3 pi. Whereas the next one, the volume is going to be pi times my radius, which is 2 squared, times my height of 6, which means I get 24 pi. Now, what is the scale factor from small to large? Just thinking about how much we multiplied by to get the dimensions, we would say the scale factor is times 2. Now thinking about the volume, we would say the scale factor, 3 pi to 24 pi, is actually times 8, which fits exactly like what we looked at a little bit ago, where we said perimeter scale factor, if that is 2, then the area scale factor must be 2 squared, and the volume scale factor is 2 cubed. So we would see, yes, that works in this case as well. All right, I'm just going to show you a couple more examples here that you can try on your own. Just remember, find the area of the base times the height. All right, and here's another one as well. All right, well, I hope this is helpful for your homework and for studying.